Our project is analyzing performance and predicting minimum resource allocation of Java microservice applications. Here, our specific focus is on microservice applications. Here, our problem is analyze the performance metrics such as throughput and latencies and develop machine learning models to predict the minimum resource allocations such as core allocation and keep allocation of selected Java microservice applications to achieve a certain level of performance. Here, our motivation is understand how the performance behave with the memory allocation, core allocation is the key to efficient design of high performance applications. And these are our objectives. The one is run experiment and collect the performance data for selected microservice applications, and the second one is carry out statistical analysis to identify the patterns, and the third one is develop machine learning models that can help to predict the minimum resource allocation to achieve a certain level of performance. And this is not our objective, that is to develop a general model that will work across all applications. That's not possible because we can't get high accuracy via general models, and workload patterns, application level parameters will differ within applications. So our specific focus is on selected microservice applications, and this is our methodology. We have done our work in these steps. In first step, we collect the data, and here we have selected two benchmark applications. The first one is prime service and second one is shop benchmark, and we used JMeter as our workload generator, and this is the sample picture. And the second step is data analysis. In this step, we perform statistical analysis of the data we collected in step 1 and identify the patterns. And third one is develop machine learning models to predict the minimum resource allocation. Here we have planned to select three models: support vector regression, XGBoost, and random forest. Why we selected those models is the performance and the resource allocation behavior is not linear, so these models will capture the non-linear behaviors, and this is the resultant analysis. So first we done the experiment on prime service, and these are the parameter values: core allocation, keep allocation, concurrency, prime number, and duration. These are the parameter values, and we have done our experiment. Here we have mentioned our prime numbers as different levels: level 1, level 2, and level 3, and these plots show the performance behavior. Here throughput gets increased with the core allocation for any combination of concurrency and keep size, and the latency is decreased for any combination of concurrency and keep allocation with core allocation. And then after that, we have trained our model. In the prime service, we have selected SPR, and we trained that model using the data. So here we can see that to achieve a certain level of latency, we can predict the minimum core to achieve that latency. And this is our second experiment on shop benchmark. Here we have, for simplicity, we have selected two APIs, order API and cards API, and we did the test. This is our workload mix for each API. What are the concurrencies? And we have selected core allocations are these 0.2, 0.4, and 0.6, and these are the four participating services, and we done the test. So after the test, we have select three machine learning models: SVR, XGBoost, and random forest, and we train those models. And we predict the latency values for those models. So here this table shows that for each combination of core allocations, what are the predictions for 3 models. So after that we get the accuracy of the each models. Among them SPR shows a good accuracy, so we selected SPR as our final model. So after that by analyzing these results to achieve a certain level of performance such as 300 millisecond latency, we can select which combinations keep the less than 300 latency, and among them we can select combination with less total core allocation. This is our final outcome. And in conclusion, we have developed the machine learning models to predict the minimum resource allocations to achieve certain level of performance. Thank you.